still got one more question for you. I'm sorry.
Formally, it's doctor, but
Doctor, I'm sorry. I'm parked in the staff lot. Is there like a parking pass I need to get, or is there free parking somewhere? That way?
Yeah,
Is it free parking or
It's-
parking pass?
I think you still need a parking pass to park over there.
Go to the police place, and that's where I just went to get mine.
Yeah, you just have to go to campus place, and then they'll send you a link, and then you just complete that.
You have to fill out a form with like your license plate.
Okay, alright. Thank
so
you.
Ardmore Tech. This is Alden. And it's a trailer, this is where the campus police are.
Alright.
Guess you could just say the police, I guess, but it's specifically campus police.
Okay. Yeah, cause I'm parked right up behind the building.
Yeah, you might
Hope I
have,
don't get towed.
not towed, but you could very well find a ticket on your car when you get out.
Ticket's fine.
This is not as bad as it used to be. My first year here, automotive was still doing classes on this campus. They hadn't opened up that, and it was, the parking sticker meant you had a hunting license. If
Really?
you got here late, then you could be driving around for 10 minutes still, waiting for somebody to pull out at just the right moment.
I was quite confused. This is my first time on the campus.
Okay, well, welcome to the main campus.
Thank you, thank you.
And then spiders over here. They're not blanket, or the Winston-Salem building still there? They were gonna tear them down at some point. Are they still there? Right. Well, potentially there's two other buildings right here.
Okay. Thank you very much.
You were asking that question, I haven't stopped the film, so would you like that removed before I post it?
Oh, I don't care.
Okay.
It's okay. Thank you for asking me that.
I tend to let it run because I'm more apt to forget to turn it back on. So,
Yeah, that's,
but I should have warned people before then.
that's all right.
Let's talk a slightly different way of doing the exact same thing. This is nothing really new, this is just, how do you deal with units? Because having to write units over and over again is a nuisance. Oh, good. So, I know my answer is gonna be in newtons. Because all my forces are in newtons. Newtons is the standard unit for force. My answer is newtons. I don't have to keep track of the units. So I could just have done 3 I hat plus 5 I hat minus 2 I hat plus the minus 6 j hat plus 4 j hat, and ended up with 6 I hat minus 2 j hat. And I need to make sure I have units in my final answer. So I have two choices here. One, I could just put parentheses around it and write newtons. Or I could write 6 newtons I hat minus 2 newtons j hat. Both of these are acceptable answers. But as you're doing the work, as you're going, the advantage of using SI units the entire time, using the standard units, is that you don't have to keep track of it. I know if it's force, my final answer will be in newtons. If I'm dealing with velocity, my final answer will be meters per second. If I'm dealing with energy, my final answer will be in joules. So if you start out with just the standard units, you're going to end up with standard units at the end, so you don't have to track yourself as you go, as long as you don't make a mistake. So I just want to throw that in there. All right, now that you had a little bit of time to sort of absorb some of it, any questions?
Actually, I do have another question.
Nathan?
If they were to like cancel out, would that just be just a zero or just
All right, so
not?
if I had 10 newtons and 10 newtons, then the total force is 0 newtons. Now, but it is a vector, so how do you indicate direction? Well, you could stick an I hat there or stick a J hat, either one. Or there's what's known as the zero vector, where you just stick a vector symbol over the zero.
Okay.
And by the way, this object would be in equilibrium. Equilibrium. There are three ways of defining equilibrium. One of them is that the total force is 0 newtons in whatever direction you want. All right. So where we're heading next is, this is the answer that we got of the problem that we just did, given this definition of I hat and J hat. Sometimes when I'm writing I hat, J hat, I'm going to stick a little perpendicular symbol right there, just put that right angle. This indicates that it's a right angle, because they should be right angles. What this is asking is, what's the magnitude of my total force? This is the total force right here, but if I ask for just the magnitude, I want to know how long is it, or if I'm writing it down, how long does it need to be? And so, let's talk about how to find that. And you probably do not appreciate it unless you've had a class in this room before. This is a new board. The old board, you would still see what was written on this board earlier, probably yesterday. That's how bad it was. So adding vectors. Two plus 3 equals 5, that's scalar math. 2 plus 3 equals somewhere between 1 and 5, that's vector math. So let's talk about how that makes any sense whatsoever. So 3 newtons and 4 newtons. This is, I'm going to start out with a simple example. There are simpler ways of doing it. We've already done something like this, just using straight up, same direction, we just add them together. But when you're adding vectors graphically, okay, thank you. We're going to use what's known as the head-to-tail method. So as I look at my arrow here, this is the head, and this is the tail. A philosophical question: are those the same number?
Yeah.
All right. So as long as it has the same magnitude here, these are scalars, it's considered the same number. Over here, as long as it has the same magnitude and direction, it's the same vector. So what I'm going to do is I'm going to take one of them. It doesn't matter which one I pick. I'm going to take one of them, and I'm just going to take the 3 Newton one there. I have some starting point, I draw 3 newtons. I now take my second vector, and I take the head, I start at the head of the first vector, and that's where the tail of the second vector is, and so then I draw the second vector. My sum is a vector from where I started to where I ended. So my sum starts where I started and it ends where I ended. Let's do this with an opposite direction. So classic blocks here, 5 newtons and 3 newtons. So I'm going to take my first vector. It doesn't matter which one I pick. I'm going to take I'll start with the one on the left. 5 newtons. So that's my starting point right there. I'm going to add the second vector. My second vector starts at the head of the first one, so that head of the first and the tail to the second, and that's 3 newtons going back. And my sum is from where I started to where I ended. That's my sum. That's 2 newtons. Here's I hat, given my convention over there. Not particularly earth-shattering for one-dimensional problems. It becomes a little bit more important for two-dimensional problems. So let's do a two-dimensional problem. Now, if done properly, they should be some sort of scale. My 4 Newton vector should be longer than my 3 Newton vector. My 5 Newton vector should be 67% longer than my 3 Newton vector. So they should be proportioned properly if you're doing the graphing. And there is one lab, which I'm not doing your lab, I'm not running your lab, but there's a lab that is often done called the force table lab, where you need to set up a scale and you're pulling out a protractor and you're making sure everything's drawn perfectly. But I'm just hand sketching right now. So if I've got 5 newtons this way, and sure, why not a box? 3 newtons that way. So I pick one of them. And again, it does not matter which one I pick. I tend to start on the left, go left to right, but it depends on my mood. I'm going to start with 5 Newton. You know, let's be a little bit more retentive about this. Set up a scale. Yeah, we got room. Ten centimeters equals 1 Newton. So I'm going to use this. Is that parallel to the tray? I heard close enough. And
Yes, sir.
Oh, it was not a comment on the way it was said.
Oh, no, I'm saying it was straight.
Well, I ruined part of that. Now, when I draw the head of the arrow here, the head of the vector, that is the endpoint right there. That is not proper. So that is where the head is. So that is my 5 Newton vector. Now I'm adding the second one, I'm adding the 3 Newton, it is going up. That's looking perpendicular, right? Helps if I don't move this. So that should be 50 centimeters long, that should be 30 centimeters long, given my scale right here. And my sum is a vector from where I started to where I ended. And I did something with the red marker. That one? Yeah, this one doesn't work as well. but- You know what? Look at it. All right, so I started over there, I ended over here. I'm just gonna draw a vector from there to there. That red line there is my sum. And of course, the math people couldn't settle for that. They had to come up with a new word. So the sum of vectors is also known as the resultant. This is the one time that I traditionally use, for whatever reason, probably childhood scars, I use the double print to represent the vector. So that's what I use for resultant. If you want to do an R with a line over it, or I guess it's a net force, so you could just do an F with the symbol over it, the vector symbol, that works too. Now that vector right there, that's the graphic, that's a graphic representation of it. It definitely has a direction, and it has a magnitude or length. Let's figure out how long it is doing this graphically on a board. We'll see how close we get. And it is 56.6 centimeters long. So how many newtons is it?
5, right? 5.5 or 5.2.
5.6, yeah.
So 5.66 newtons. It helps if I actually write the numbers. There we go, 5.66 newtons. Just because of the scale I have right there. But I also, because my 3 Newton and 5 Newton are perpendicular to each other, this is a right angle down here. It's supposed to be, at least. How can I find the length of the long side?
I think it's called Pythagorean Theorem, but I'm not 100% sure.
We got a nod right here. Anyone else want to back them up or say, who raised you?
I think he's right. Was it a squared plus b squared equals c squared?
That's the one, and it is Pythagorean theorem.
Yeah.
So if I have a right triangle, and all a right triangle means is it's a triangle and one of the angles is a right angle or 90 degrees. A right triangle, length A, B, and C. As Lay said, a squared plus b squared equals c squared. So 3 squared plus the 5 squared, notice I'm not writing the units in there because I know what my units are going to be in the end, is equal to r squared. Doing the fancy math here, that's 9 plus, thank you. It feels like it's been a long day, which is 34. So r is equal to the square root of 34 newtons. Now, square root of 34 is a number. Anyone happen to have a calculator with him or her? Let's see how close we got doing it graphically. Oh, you don't want to do square root of 34?
Yeah. 5.83.
Not too bad. If you do physics long enough, you'll celebrate victories that being that close. Or if I'm to believe every physics lab ever done by students, we got a whole bunch of Nobel Prizes coming our way. A lot of things that really defy convention. Especially people who work back. That corner back there, I claim is haunted. The strangest results we get in lab come from over there. If you're superstitious, I apologize then. All right, so that's our magnitude, but the direction is up at that angle right there. Now, if this were physics 151 or 251, I would expect you to know how to calculate what this angle is. I don't expect 110 students to know how to calculate the angle. However, given that, anyone in here know how to calculate that angle? It's a trig problem. I'm gonna guess